exactly 0.68, but it's the closest to 0.68. So let's move on. So the following is the equation of a circle in the xy plane with the center at 0, 4 and radius with endpoint 4, 3 or 5. So basically I have to find out the distance for the radius. So what's the distance between these both? We will just use the distance formula. 0 minus 4 upon 3 whole square plus 4 minus 5 whole square. And we're going to root this entire thing. So let's just find out the answer real quick. 1 3 square plus 4 minus. The radius is 5 upon 3. So the circle equation is x minus h whole square plus y minus k whole square is equals to r square. So on the other side you have the square of the radius. So the square of the radius is 25 upon 9. So these two options are automatically cancelled out. Next, the center is at 0. So hk is equals to 0, 4. So by that virtue, you should be getting x square plus y minus 4 whole square is equals to 25 upon 9 as the equation. This corresponds with A. So, yeah. Also, another really important thing to note is to not get confused because of the signs. For example, if you have x plus h whole square plus y plus h whole square is equals to r square, then the center of the circle will be um, minus h minus k, because it's the opposite sign to that which is actually given to us in the equation in the closed box or this bracket. So this is just an easy way to remember it. If the center of the circle is at 4, then we will write minus 4 and vice versa. So A is the answer. The equation above expresses the approximate height h in meters of ball t seconds after it is launched vertically upwards from ground with an initial velocity of 25 meters per second. Approximately how many seconds will the ball hit the ground? So basically, initial velocity of 25 meters per second. Because when the ball will hit the ground, its height from the ground will actually be 0. So you can just write is minus 4.9 t square plus 25t, and change shifting it to the other side. So you will get this quadratic equation, and we're just gonna have to solve this quadratic equation using our calculator. So just solve it, and you get so your values of t minus 250 upon 49 or 0. Weird. Actually, yeah. So the equation, it does not allow us to actually shift this on the other side. So basically, let's just try it with the negative values themselves and see what answers we're getting. So minus 4.9, then 25, and then 0. Yeah, 250 upon 49. So the positive answer is 5.1. The closest answer to this is D. So 25 answer is D. Just check that. Yes, it's D. So let's look at the next ones. Katerina is a botanist studying the production of pears by two types of pear trees. She noticed that type A produces 20% more than type B did. Based on Katerina's observation, if type A produced 144, then how many did type B use? So type A produces 20% more. So basically 1.20 x. Actually, I'm sorry, what am I writing? Type A produces 20% more pairs than type B did. So if we put type B as Y, then type B is actually so basically Y is the number of pairs that are produced by B, So 144 is 20% more than y. So 1.2y is equals to 144. Just to go over it again, if type A is producing 20% more pairs and type A is producing 144, then that means that if y is the number of pairs produced by type B, then this is 20% more, right? And 20% more would mean that it is 1.2 of y, or 120 upon 100 of y, because it's already 100%. It's greater than y, and it's 20% greater than y. So basically, if we solve this, we get the value of y as 144 divided by 1.2, and therefore 120, which is the answer B. Okay. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region. Each region is a square and has side of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground in each region. Uh, so which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Okay, so basically the entire field is 10 meters by 10 meters, right? So this is the entire field, 10 by 10. And this is just a small region that's taken, and these are the number of earthworms that are recorded in this region. So, for example, if a reasonable estimate here, because all of these options are like 150 or 1, it's basically they're building on from 15. So basically, if we just take the reasonable estimate as 150, right? The average of all of these is 150. Then the 150 is the number of earthworms in a square of side 1 centimeter. So what will it be in a square of side 10 centimeter? Or let's just talk about area, right? Here the area is 1 meter square, and here the overall area is 100 meter square. So if there's 150 in 1 meter square, then how many are there in 100 meter square? If you calculate x, you will get the value as 15,000. So the answer here is C. Just to go over this again, you basically have been given the number of earthworms in different regions, and all of these regions are squares which basically have an area of 1 meter square because they measure 1 by 1. And you have the entire field being a square with 10 by 10, each side is 10, and therefore the overall area is 100 meter square. So there's 150 earthworms in 1 meter square, then there should be x earthworms in 100 meter square. And basically going to use proportion. And the answer you get by using this is C. Okay, so let's move on. If the system of inequalities y is greater or equal to 2x plus 1, so basically let's just draw this out, right? 2x plus 1 is going to look something like this, okay? And half x minus 1 is going to look something like this. Actually, just a second. Just going to make this a bit steeper, and this is the half x minus 1 line. And y is greater. So here, this is y. Here, this is y. So basically, the region where both of these inequalities are overlapping is this region. So this lies in quadrant 1, 2, and 3. So which quadrant does not contain any solution to the equation? Quadrant 4. So in such questions, you basically are advised to draw out the function yourself, or draw out the inequality yourself. This is basically going to be a line with gradient 2 and y-intercept 1. This is going to be a line with gradient 1 upon 2 and y-intercept minus 1. You're going to see that if the sign is greater or equal to, then it's going to face upwards. And here in both of these cases, it's facing upwards, and the region where both of these are intersecting is this region. So there's that. Let me just check this. 28 is C. Perfect. Okay, so 29. For a polynomial px, the value of p3 is minus 2. Which of the following must be true? So this is about remainder factor theorem. And so let's just go through all of the options. X minus 5 would be a factor of px if p5 is equal to 0. If we input 5, the answer will be 0. Similarly, here x minus 2 is a factor of px if p2 is equal to 0. X plus 2 is a factor of px if p minus 2 is equal to 0. So they've not actually given us this information. The information that they've given us is when the value of p3, when we basically input 3 into this function or this polynomial, the answer that we get is minus 2. So that means minus 2 is the remainder when it is divided by x minus 3. This is covered in depth under the lecture for remainder factor theorem, which will be up a few days after the video for this test is up. So basically what you need to know for now is something is a factor if, for example, x minus 5 is a factor if px is equal to, if p5 is equal to 0. And if something is not a factor, for example, x minus 3 is not a factor, then p3 will give you the remainder. When you input 3 into this equation, you will get the remainder of the polynomial, right? So by this virtue, the answer for this question is D. Which of the following is an equivalent form of the equation of the graph shown in the xy plane from which coordinate of vertex A can be identified as a constant, as constants in the equation? So this, because basically when you have a quadratic equation written like this, basically x minus 1 whole square minus 16, then we know that the vertex is 1 and minus 16, and this is something that's covered under quadratics. So basically x minus h whole square minus k, for this, the center, no sorry, not the center, the vertex is h and minus k, right? So that is about it. So D should be the answer, because you can clearly see here that the x value of the minimum point or the vertex is 1 and the y value is minus 16. The vertex can either be a maximum point or a minimum point. It's just the turning point. So you could have a vertex like this, or you could have a vertex like this. This one is the maximum curve. This one is the minimum one. So that is it.